Hi, I'm Jacquie Parr, and I'm here to show you the features of using channel bonding on a VXG, feeding it into a UXA. We're going to take a 2-channel instrument. Each channel alone gives you 2.5 gigahertz of bandwidth. Combined, we can make a 5 gigahertz bandwidth signal measurement. For this measurement, I'm going to show you a QPSK signal at 3.6 gigahertz. So now, to start with, we're going to just measure a signal at 12 gigahertz, 0 dBm. So I'm going to set that up. This is source setup. We started a preset mode where we have both channels have their own path. We're now going to go in and configure the channels for channel bonding. And we select this configuration, apply it, and now we see both signals combine to create one output. This is our combiner over here that will feed the signal directly now into the UXA. So now I'm in the custom modulation setup. I'm setting up a QPSK signal with a total bandwidth of 5.12 gigasamples, and I'm going to measure basically a 3.6 gigahertz bandwidth. So I generate the waveform, and at this point I go back out to the home, and you will notice that here in the signal block that the waveform has been generated and it is automatically playing. So I open up the waveform. I'm going to set my occupied bandwidth to 3.6 gigahertz. And I'm going to now configure channel bonding. And so you always do make sure that you're testing your test connection, that you really are connected to the UXA. It is successful here. And now I go in and I set up my calibration. I'm going to keep it fairly simple for this measurement. I'm going to turn off ACP and just measure EVM. And I'm going to go into the advanced menu and turn off compaction. I start my calibration, and now you'll notice that this has obviously triggered the UXA over here, and it is doing the calibration between the two boxes. This takes about 2 minutes to complete. Okay, so now the channel bonding is complete. You can verify this because you see that the extension of the file has changed to a .bnd file. Looking over at the UXA, we have a signal on the screen. If I auto-tune it, there's our 3.6 gigahertz bandwidth. Okay, so I'm now going to use the UXA. I'm going to use the feature of going into the VSA software. And I'm going to launch VSA. This takes a couple of minutes. I'm going to set my carrier frequency to 12 gigahertz, and I'm going to do an auto range. Okay, now I'm going to demod the measurement. So I go into measurement setup. I'm going to select the type as a general waveform, general purpose, and I'm going to select custom IQ. Set up the custom IQ demod properties. I'm going to edit the constellation menu here, and I'm going to actually use the preset to standard configuration and set up a QPSK signal. It's over there, just 4 basic points. Select OK. I'm going to change the sample rate to 3 gigahertz. Symbol rate to 500 megahertz. So I went into the measure setup menu. I demodulated this signal, set it up for minimize EVM. I have now given you 4 displays, so now we can see the constellation. We can see the measurement results over here and our actual bandwidth. In summary, what we did is we took the VXG, took the 2 channels, used a combiner, bonded them together, calibrated the signal for use on the UXA. We opened up the VSA software. We demodulated the signal. And we now have a very clean 3.6 gigahertz bandwidth signal that could be used for 5G&R, aerospace and defense, and other applications.